The representation of vectors in a coordinate system varies upon the choice of basis. The blue vector, for example, is represented as 2, 2 in this orthonormal system. However, in addition to having the standard basis, this Euclidean space can have different bases, such as the basis vectors 1, 1 and minus 1, 1. The question now goes as follows. How is the blue vector represented up to this choice of basis? Apparently, the vector will have the coordinates 2, 0. It's important here to note that the coordinates are nothing but scalars for the basis vectors. The change of basis in this case is done by applying this matrix. With that being said, it's not a surprise now that the new representation of the vector is computed through matrix vector multiplication by the original representation of the vector. Nevertheless, we seek an answer to the case when none of the two bases is the standard basis of R2. That is, what if we have these two bases? In other words, if we know the representation of the vector in one of the coordinate systems, can we find the representation of the same vector in different systems? That's the question. How can we convert one of them to another? That's better found algebraically. In fact, the targeted vector V was some vector V1 and V2 before it was transformed to the vector V. Accordingly, we can benefit from the fact that the column vectors of the matrices form a basis. And so the matrices are invertible. So to find V1 in terms of V2 or vice versa, we multiply by the inverse of one of the matrices, both sides. For more similar topics, stay tuned. For more about linear algebra, check these videos. Thanks for watching and don't forget to hit the like and subscribe buttons.